Hey guys, a pleasant day! We are from STEM 12 St. Patricia. And today, we're going to talk about uniformly accelerated motion. In this video, I assure you will learn more because we'll discuss problems and show solutions that will help you understand our topic further.
First, what does it mean? This refers to a situation in which an object undergoes a constant or uniform change in velocity over a specific time. This means that an object moves at a constant rate of acceleration. To put that into perspective, suppose that a ball rolls down on a ramp. Notice that the ball has a constant change in velocity every second. That is because the ball has a constant or uniform acceleration.
This is a graph of every distance it travels and its change in velocity for every second with an acceleration of 0.5 meters per second squared.
Now let's discuss further on how we can solve the problems for uniformly accelerated motion. We can use four kinetic equations to solve the problems.
So how do we derive these four kinetic equations? We will show you how.
In equation 1, we are going to have a formula for final velocity, and we are going to derive it using the formula of acceleration, which is final velocity minus initial velocity over time. So first is we are going to multiply both sides by time so we can be able to cancel the time from the right side of the equation. After that, we are going to transpose the initial velocity. Now, we have final velocity equal initial velocity plus acceleration times time. Now, let's move on to the second equation. In here, we are going to have a distance formula. And to do that, we are going to combine two formulas of speed. The first formula will be speed equals distance over time. And the second formula is speed equals final velocity plus initial velocity over 2. Using the second formula, we are going to substitute speed in distance over time. As you can see, we need to remove the time under distance to have a distance formula. So to cancel it, we need to multiply it by time on both sides of the equation. Now we have distance equals final velocity plus initial velocity over 2 times time.
In equation 3, we're going to use the formula of distance in equation 2, but substitute the formula of time on time, which is final velocity minus initial velocity over acceleration. After substituting, we will use the FOIL method to combine the two. Then we will have distance equal to final velocity squared minus initial velocity squared over 2 times acceleration. In equation 4, we will use equation 3, but change the final velocity to equation 1, then expand it since it is squared. After expanding it, we will use FOIL method, then combine the line terms. After that, we will have distance is equal to 2 times initial velocity times acceleration times time plus acceleration squared times time squared over 2 times acceleration. Then separate the numerator and cancel the 2 and the acceleration, so we will be left with distance equal to initial velocity times time plus 1/2 acceleration times time squared.
We can use three different equations to solve the displacement of an object and one to solve the final velocity. But keep in mind that we can also use all these equations to solve for time, acceleration, and initial velocity by deriving the equations.
Let's put this equation into use. A ball is dropped from the third floor in a uniformly accelerated motion, and the goal is to find the final velocity of the ball and the height of the building.
First, we need to time the ball from its release and before it hits the ground. Now that we have the time, let's go ahead and calculate the height and the final velocity.
So let's first start with the final velocity. Since the ball was dropped at rest, we can substitute the v initial with 0 meters per second. Since this is a free fall motion, we know that the acceleration is negative 9.8 meters per second squared. And the time is, if we calculate this, the final velocity would be.
Now, let's move on with the height of the building. In computing the height of the building, we have the formula distance equals to final velocity plus the initial velocity divided by 2 multiplied to its time. So we have negative 14.7 meter per second as its final velocity plus 0 meter per second as its initial velocity since the ball is at rest, divided by 2 multiplied to 1.5 seconds as its time the answer will be negative 11.0 meters. But since we're talking about the height of the building, the answer should always be positive, 11.0 meters.
Uniformly accelerated motion can occur in many situations, such as moving cars and airplanes taking off. Now, these motions can formulate a constant acceleration.
However, the acceleration of falling objects can be easily identified as it has a uniform acceleration of negative 9.8 meter per second squared due to gravity, like the experiment we did in this video.
Remember that using the correct equations to solve the UAM questions can help you get correct and logical answers.
We hope we did a clear representation of what uniformly accelerated motion is, and we hope you understand. Thank you for watching.